Adenosine triphosphate or ATP molecules are termed as energy coins of the cells. Guys, have you ever wondered why the hydrolysis of ATP into ADP and inorganic phosphate releases energy? What is the logic behind this energy release? What is the secret of ATP that whenever it is getting hydrolyzed, there will be production of energy? Let's learn about the same in this video. Let's start the things from a very basic concept. Assume that we are having a chemical process where a reactant is converting into product. And we are having a situation where the product is more stable in comparison to reactant. Now what will happen? The reactant will convert into product spontaneously without any efforts because every system, every process tries to achieve the stability. So things will move quickly from less stability to more stability and whole thing will be spontaneous. Now whenever the word spontaneous comes into the picture, then we know that what is negative? The Gibbs free energy is negative. The process will be having negative delta G. And negative delta G automatically means energy is getting released. So, for a chemical process or for a biological process, we can easily explain the release of energy by explaining the stability of product in comparison to reactant. So if the product is having higher stability than the reactant, then there will be release of energy. Now let's apply the same logic to ATP hydrolysis. So this is our ATP hydrolysis where ATP is converting into ADP and inorganic phosphate. If we are able to explain that the product of hydrolysis, that is ADP, and inorganic phosphate are more stable than ATP, then the problem is solved. We will be able to say that ATP hydrolysis is giving energy because products are more stable than reactant. The process is spontaneous, free energy is negative, and energy is released. So now our task is not to talk about energy. Now our task is to talk about the stability of ADP and inorganic phosphate in comparison to ATP. Now, if you look at the whole process closely, then you will see that the structure of ATP is burdened with internal electrostatic repulsion between negative charges. So we are having 1, 2, 3 negative charges. They are close to each other. They will be repelling each other electrostatically. So the molecule is unstable because of internal electrostatic repulsion. On the other hand, if you look at the structure of ADP, one inorganic phosphate has been removed, so there are only two negative charges. So internal electrostatic repulsion is less. So we can say that the structure of ADP is having relief from internal electrostatic repulsion and getting stabilized in comparison to ATP. Now, the first reason of achieving the stability is relief in internal electrostatic repulsion. The second reason is also an interesting reason. If you look at it closely, we'll find that stability also getting increased because the products ADP and inorganic phosphates are having more resonating structures than the reactant ATP. So you can see that in the inorganic phosphate we are having multiple resonating structure. ADP is also having resonance. So we are having more resonating structure in products in comparison to ATP. And when resonating structures are increasing, stability is automatically increasing. So we are having these two stability increasing factors governing the spontaneous hydrolysis of ATP and ultimate release of energy. I hope you have understood that by explaining the stability of products, we can easily explain the energy release in a process. We are having another interesting molecule named phosphoenol pyruvate. When it converts into pyruvate, then the highest amount of energy is released in the cellular system. So when we always say that phosphoenol pyruvate is highest energy giving molecule. Now, you apply the logic of stability on this reaction and try to explain the reason behind the release of this much high amount of energy. You can give your answers in the comment box. If you understood the concept, if you liked the video, then please subscribe our channel. We are Bio Nerd Central.